Here's problem 1030. When a wheel is rolling without slipping, the magnitude of the velocity relative to the ground is greatest at... Well, let's take a look at the wheel. As it's rolling, it is doing two kinds of motions that we can think of simultaneously. One is it's rotating around its center of mass, so we have rotation about its center of mass. And if we look at this, then every point on the rim is moving at some velocity around this center of mass. And in particular, the point at the bottom is moving to the left as we're going clockwise, and the point on the top is moving to the right. So we're going to add this motion to the wheel translating in a forward direction. So we have translation. And in this case, then the whole object is acting as one, moving to the right, where the center of mass is moving with the same velocity as well as every other point on the object as it's translating to the right. If we add these two motions together, we get the rolling motion of the wheel. And if we look in particular at the contact point at the bottom, we have that point with two velocities, one going to the left and one going to the right. So that point actually is momentarily stationary. The point in the middle, the center of mass, is actually nothing in the rotation, but then translating, it's moving at a velocity v. And the point at the top is actually moving at twice the velocity, 2v, twice the velocity of the center of mass. So at that moment, that point on the wheel is moving at the greatest velocity. So the point at the top of the wheel, opposite the point of contact with the ground, is moving at twice the velocity of the wheel itself as it's translating. The point on the ground is actually momentarily stationary. So we choose answer C.